Hey math kids, today we're going to talk about completing the square. This is section 2.bb, and we are going to try this. Okay, so this is kind of a bigger process, so you may want to take notes on the video. Hopefully you took notes in class, actually, and we'll just keep going. I'll try to explain it the best I can. So we need to have a quadratic, so that means we need to have something that's ax squared plus bx plus c is equal to y. We have that. Our a would be 1, our b would be 2, and our c would be -1. So since it's quadratic, we move on to the next idea. And we're going to set this equal to 0. So we're just replacing the y with a 0. Now the next step, we want to move the constant, or our c term, onto the other side. So we add 1, and so we have 1 equals x squared plus 2x. Now, I'm not going to do this step in this problem, but if your a is not a 1, so in this case it's a 1, if it's not, we would divide everything by that number. Since it's 1, dividing by 1 wouldn't do anything, so I'm going to move on to the next step. The next step is this is called the L step, and what we do is we divide by 2, and then we square. And so if we divide by 2, we get a 1, and then if we square 1, we still get a 1. Now what we're going to do is we're going to add that to both sides of the equation. Okay, so on the left side, we get 1 plus 1 is 2. Then on this part, I'm just going to rewrite what we have, and then we'll talk about how to deal with that. The next step I call the magic step, and it's always going to be parentheses that are being squared. Right here, we just write the variable, so x in this case, and then we come back to the elbow of the L step and choose that number. That's a positive 1, so I say plus 1. This is still equal to 2. Now if you need to convince yourself that this is true, you could multiply this out. You could say x plus 1 times x plus 1. If you do it correctly, you will end up getting this answer. Okay, that's how you could check to see if you did it right. Now, for this video, that's where we're going to stop. That's what I'm calling completing the square, is going up to this point. The reason why we stop here is because from this point on, we can do a number of things, but we'll kind of split from this point. But most of the stuff that we use completing the square for will go to this point, and then we'll split off in different directions to finish it. So I'm going to do one more problem. So I'm going to say y is equal to 3x squared plus 6x plus 12. So we want to first identify that it's quadratic. So ax squared plus bx plus c is equal to y. It is quadratic, and then we want to replace our y with a 0. After we do that, we move the c term onto the other side. So in this case, we subtract 12. So we're left with -12 equals 3x squared plus 6x. Now this is the step that I didn't get to do in the previous one, but you take the a term, or just the a coefficient, so 3 in this case, you divide all the pieces by that number. So we get -4 equals x squared plus 2x. From here, we do the L step. So once again, we divide by 2 to get 1, and then we square. This won't always be the same number, I know in both my examples that's true, but we take 1 times 1, that ends up being 1, and we add that to both sides of the equation. Do a little bit of simplification right here. we get -3 is equal to x squared plus 2x plus 1. This is where we do the magic step. So you do parentheses that are being squared, and what you do is you write the variable, and then you come to this. This is a positive one, so we say plus 1. Once again, it's the elbow of the L step. Okay, and then this is where we're going to stop on this video. If you need additional help, please come to Math Lab. Until then, calculator.